What up, dudes? How's it going with you folks? Let's get this party started with statistics today. All right, so some of you, uh, hold on. Please delete, do not, what? Oh, interesting. Someone is spamming us. All right, sorry. Yes, oh no, I didn't turn on my webcam. I just turned on my screen share. Okay, so check this out. We're going to have to cover statistics, and it's not that I'm done with exponentials. There's a lot more to have to go on with exponentials, like, for example, logarithms and all of that kind of stuff. I am kind of doing a quick stint on statistics. I'm going to go through the whole chapter. The chapter on statistics is only like 5 parts, and it's really short and really kind of easy. And then if we have time, as we have more time, I'm going to get into the last parts of exponentials. Wait, oh, you can't see my screen. Okay, sorry. Screen share, full screen, allow. Oh, allow and remember. Okay. Let me know. It's probably going to give me, hold on. Don't update now. I know. Give it a sec. Give it a second, dude. All right. We up? Okay. So like I said, I'm not done with statistics, or I'm not done with exponentials. There is a lot more. There's like 15 chapters to this thing, and I think we're only on chapter 6 of exponentials. But I can't finish all of exponentials and cover statistics while I'm there's 15 parts of that thing. It's ridiculously long. There's a lot of parts to exponentials. And it's fascinating to me. But I honestly think that we need to cover statistics so that way you have a well-rounded Algebra 2 understanding before you guys take any Algebra 2 tests or before you guys like graduate from my course, and then like you leave my class, and I like your teacher next time will say, well, remember from statistics, and you guys will be like, Mr. Dalday never taught us statistics, and then that person's going to say, well, Mr. Dalday's an idiot. You know what I mean? So I don't want to be called an idiot, so I want to be able to at least teach you some statistics. Plus, to be honest with you, I feel like this is the best stuff that you can get in terms of like if you want to go into science. So I know that I constantly pick on you, Bradley. I think it's maybe because you constantly pick on me. But Bradley, you want to go into science, so you're going to have to learn a lot of these statistics because, I mean, this is a lot of, like, I actually took a statistics course last summer. I think it was, this past summer. And what happened was I was actually really good at the class, even though I've never formally took a statistics course until this past summer. The reason why I was so darn good at this class was because I had so many years of experimentation and doing research. And when you're doing experimentation and research, you have to learn statistics. Cool? Some of it's pretty straightforward. Most of it I taught myself. But yeah, and Lucas, an epidemiologist, has to do statistics. Also, Sophia, I forgot exactly what it is you want to go into, but I think it was something where in the medical field. Oh, economics. Oh man, that's all you do is statistics, or neurology. Well, I don't know how much statistics a neurologist does, but anyway. So statistics is what you use when you gather data. And so we're going to look at how we arrange the different types of data and all of that kind of stuff. First thing I want to look at is this collection of data right here. So what we did was we randomly selected high school students and interviewed them with how many times they spent on Facebook or Instagram or Twitter or Tweeter or Twatter or whatever it's called nowadays. And then what else do you guys use? Do you guys use like Photobomb or I don't know. Anyway, all of those social media sites. And here's the here's the things that we got. Here's the number of hours. So I started putting those into the table. Let's see. I've got 5, 3, 6, 4, 3, 3. Okay, all right. So let me just finish putting in all the data into the thing. 6, 5, 4, 9, 3, 1, 2, 5, 4. Cool. And then what I'm going to do is I'm going to make what we call a number line plot. Now a number line plot looks like this right here. And I would label this 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up till 9. So starting at 1, put the numbers underneath it till it goes to 9. And I would count how many times does 2 appear. Now I see once, twice, 3 times, 4 times I'm thinking. Yeah, would you guys agree? How many times in this list does 2 appear? 4 times. Okay, cool. Now, I am a lazy dude, so I'm going to have the computer do it. I'm going to go to Insert, Chart. Let's insert a histogram, which is what it's called. And then what I'm going to do is I'm going to edit this thing, I think. Here, wait, I did it wrong. Hold on. I need to insert chart. I want to do a histogram. I want to customize it. I want the bins to be, bucket size to be 1. There we go. And I think that's good. No need a table of contents. Yeah, no need the legend. None. Now here's my question is, I can't really, let's see, oh, I know what I did wrong. I was like, all right, so check this out. This block is, the block follows the number on the left. So this is the plot for the number of 1s we have. And here's the plot for the number of 2s we have. And here's the plot for the number of 3s we have, and all of that kind of stuff, okay? I think that I accidentally did this plot a little bit bad. I need to add in an extra 2 because I think my 2 got deleted on my graph. So let me insert that thing again because this thing is wrong. Insert a histogram, customize, no legend, and bucket size will be 1. Okay. All right. So, do you guys see the graph and how it works and everything? All right, cool. So this is nice because now we can actually use the graph to answer some questions. What are some important things? Well, one of the important things is we probably should label our graph. So let me see if I can advance edit. Okay, let me go to, I want to call the x-axis, I want to call it number of hours wasted. You guys are thinking Instagram and Facebook is not wasted hours? No. Well, I think it is. All right. And then this would be number of people. Okay. So my graph has I labeled my boundaries. I labeled the axis. Okay, let's see. That should be good. All right. Another thing that would be good, or that you want to know, and this is also a math question or a math term, is you want to find the range of your data. The range of your data is very easy. All you do is you take the highest number and you subtract the lowest number. And that gives you the range as to where your data falls between. Because obviously, your data is going to fall between the highest number and the lowest number. So in this case, it's 9 and 1. So what is my range on this thing? 8 hours. Good. It's between 8 hours. Cool? But immediately, once we do this, we can say, all right, we can plot exactly, or we can immediately tell, like, some data. Based off of this, what is the greatest amount of hours that high school students spent on Facebook? Looking at this graph. And here, I'll tell you what, I'll share this graph with everyone. This will be stats. I'll share it with you guys so you guys can just open it up in a Google Doc or whatever. All right. It does include 9. What are you talking about? 9 is there. See? The box. Oh, you're saying when I ask what is the range, the answer is 8, but your question is why isn't it 9? Is that what you're saying? Okay, no. The answer is what is the gap between the biggest and the smallest measurement? So the gap between the biggest and the smallest measurement is actually the biggest measurement that I see in this list of numbers is the number 9. And the smallest measurement I see is 1. So apparently nobody spends 0 hours. If somebody spends 0 hours, then this would be like my range would be 9. But since nobody spent 0 hours and the smallest somebody spent was 1 hour, then my range is 8. And what the gap represents is, or the range represents, is the size between which your numbers can fall in. Like, for example, how not necessarily how extreme it can get, but how far between it's basically a measurement of how far is it between the highest and the smallest measurement. That's what it is. Does that kind of make sense? All right. Okay, let's do this one. What's the greatest number of hours that a high school student spends on Facebook or Instagram? 9. Very good. Because the highest number you see here is 9. What is the greatest number, or what is the least number of hours that you see? Well, that's pretty easy. All right. What is the frequency for the data for students who use it for 6 hours? Very good. I asked the question kind of, actually I read the question verbatim, but I want you guys to kind of understand what I'm saying. What I'm asking is, for the students who use it 6 hours, how frequent did you see the number 6? Apparently you saw it 3 times. See, it goes up to the number 3. Make sense? All right, which data entry has the greatest frequency? Okay, cool. On average, the greatest number is 3. So that means you'll have 3 hours is what most of the students will spend. 6 people spent that, as opposed to even the next closest one, which is 4, which is only 5 people. Cool? All right, let's try another one. And I'll show you guys how to make these graphs from scratch. They're very easy, okay? So here's the data that they want me to do. So what I did just now is I graphed this thing for you. I showed you how to graph it. And then I included all, or I asked you all of these questions. All right. So let's try this one. 5, 6, 12, 8, 5, 6, 7, 9, 10, 5, 11, 7, 8, 6, 7, 9, 8, 7, 6, 6. Okay, so this is the, let's see, the amount of time in minutes that 20 randomly selected students spend in line at the cafeteria. Okay, so I randomly select 20 students in line, and I ask them, how long did you spend today in line at the cafeteria? And this is all of my answers. I've got 20 different entries. Cool? All right. What is the longest time that a student waited? 12. Very good. 12 minutes. It's right here. What is the most, or what is the least frequent time that a student waited? See, I guess I'm trying to make a point here. The point that I'm trying to make is it's hard to tell when you don't have a graph. Right? You can almost instantly, immediately read it off to me when you have a graph. So let me show you how to make a graph on this. What we're going to make is what we call a histogram. I just highlight the thing. I go Insert, Chart. I'm going to put what we call a histogram. And what I'm going to have to do is I'm going to have to adjust the bucket size. Can we do this when you're doing, or can we do what you're doing? Yeah, you can do this for my quizzes, sure. The histograms are not hard to make at all when you want to do it by hand. I mean, you just make a number line and do all of this stuff. I'm just showing you how the computer does it. That way we can speed up time. What a bucket size is it's kind of adjusting the range of each, or the horizontal size of each of these bars. So apparently it's going from, it's about 1.5. That's the range. So if it's a number between 4.5 to 6, then it's going to put it in this bin. And if it's a number between 6 and 1.5, and I don't like that 1.5 kind of thing, I'm going to make my bucket size 1. So if it's between 5 and 6, if it's between 6 and 7, it goes here. If it's 7 and 8, it goes here. 8, 9, 9 and 10, blah, blah, blah. Got it? Okay. All right, so I'm going to press Enter. Okay, so check this out. Here's what our histogram looks like. And if you look now, and when I ask you what is the shortest amount of, or what is the least frequent, you can say, well, the least frequent is 10, 11, and 12. Cool? Now, why the heck would they do these half measurements? What is up with that? 0, 5. Let's see if that helps. How do I change this chart? Okay, let's see. Sorry, I don't know why I did this y-axis like that. I think it's dumb. The vertical axis, I would like you to scale. Okay, wait. I would like for you to go from 0 to 5, and I would like you to go from a scale of I have no idea why it does that. I don't even know how to fix it. Well, it's alright. Because it doesn't necessarily change our data and everything. Okay, let's see. What time is observed the most with the greatest frequency? 6 minutes. Very good. Very good. This is sometimes called the mode. You know how I talked about the average, which is the mean, median, and mode? By the way, are there more than 3 people in this class? Because only 3 people are talking. All right. This is called the mode, the number that appears the most. All right. Here we go. Let's try this one. And I think this might actually be on your homework, which I'm giving you the answers to already. So let's just do it. Oh, by the way, I forgot to ask. Let me ask this real quick. What's the range between, or what's the range of this data? Nope. There we go. Sophia's got it. Bradley's got it. It's 7. Because it's 12 minus 5. So that means what that's saying, and I think that what Sophia's been asking is, what is the physical meaning of that? And I'm saying the data falls within 7 units of each other. Does that make sense? It's the smallest data to the biggest data falls within 7 units of each other. And I suppose that if you want to do an experiment and you want to measure like how good your results are or something like that, you'll want that range to be small. You know what I mean? Because like, what if I did this? What if I did 43, and one will be 2. Okay, check this out. Previously, I had a nice little graph. It kind of had this shape that was in the middle like that. I added some freaky data out here. 43 out here and 2 over here. It's not impossible. This is a measurement of how long they stood in line. I mean, maybe this person fell asleep in line. People just cut in front of them, and they took 43 minutes to get from the back of the line to the front of the line. Doesn't matter. You see what I mean? And this is a perfectly fine graph. Yeah, I know, it's hard to read. I agree with you. It's hard to read. It's because they adjusted all of these things to include decimals, and I don't really like that, but you know, what are you going to do? You included some freaky data, Mr. Dalday, so anyway. Yeah, you're absolutely right. It is hard to read. On this histogram, what is the range? It's 41. Yeah, it's 43 minus 2. There's 41 spaces between the lowest and the highest piece of data. Which means your data is very spread out. Does that make sense? Whereas before, on my graph before, this range was 7. Oh, Sophia, yeah, it is the x-axis, and the x-axis was labeled funny, but if you look at the data, you knew that it landed at 43 and 2. So that was 43 minus 2 is 41. Yeah. All right. But what I'm saying here is, like, the point I was trying to make is this. This graph right here, okay, here, watch. I'll redo it. Okay, look. I changed the data, and I just messed with 2 of the numbers. I made one of them a 43 and the other number a 2. Okay? And it messed up my graph. It messed up my x-axis. Even though they labeled it 1.23, this could be hanging out right exactly at 2. Right. So the range on this sucker is the biggest piece of data over here. And to be honest with you, the best way to do it is to look at the data in this case, not the graph, minus the smallest value, which is 2. It's 41. Pretty straightforward. This data right here is much more spread out than the previous data that I had, whereas this range is just 7. What's nice about the data on this one is it's clustered close together, because I know that the furthest apart that they can get is 7 units. Whereas when I changed it, that range was much bigger. So there's, like I would say that data is a lot more wide. It's measuring the width of your data, how far the outliers are. Does that kind of make sense to you? So what I'm trying to do is talk about a physical representation of what the range actually measures and what it is. All right, let's see. This one, they already gave us the data plot, which is cool. They didn't give us a little table. That's fine. I'm cool with that. All right. According to the dot plot provided above, what is the most KLE has scored in his 15 games of basketball? So this is a measurement of KLE and his game of playing basketball. So the most he scored was 19 points. Okay, cool. What is the least? 9. Very good. I mean, you just literally read it off the graph, and that's it. All right. How many points has KLE scored with the greatest frequency? So, yeah, okay, cool. He scored 12 points the most in all of his games. And would the prediction that KLE scored 17... Okay, all right, here's another question. I'm going to ask this one. In how many games did KLE score over 15 points? Good, 2. And I'm glad you answered it that way, because I put an emphasis on the word over 15 points, because I don't think this one counts. Would a prediction that KLE will score 17 points in his next game be accurate? Do you think that he'll score 17 points? Unlikely, but possible, because he rarely ever scored 17. Yes, I agree. What is the most likely amount of points he will score? 12. Good. If he scored 12, I would be not surprised. If he scored 13 or 11, still, I wouldn't be as surprised. But if he scored 17 or 19 or 2, those would be outliers. You know what I mean? Okay, all right. What is the range? Your range in this case is 10. Very good. It's just the biggest number minus the smallest number. Now, imagine if this were a measurement of how close you got to a bullseye or something. Or no, let's just keep it with the same story. This is the basketball games and all of that kind of stuff. Okay. Ideally, your coach would want you to have a small range. He doesn't want too many pieces of data on this side. And yeah, I'm sure he's fine with having too many pieces of data on the right side. You know what I mean? But exactly, Sophia. If it has a smaller range, that means I know in my head I can count on that person to score, to score a certain amount of points. And then I can keep that in mind when I'm coaching and strategizing how to win the game. Pretend the 17 and 19 were there. What would the range be then? It would be 6. There we go. Now, obviously, the coach wants to move this thing higher as possible. And I'm sure that the coach has no problem with, KLE scoring 17 and 19 as well, even though those are outliers. But you want to keep your range small, because it kind of provides more, I guess, in the best word, accuracy. Right? Like, it also provides more consistency. So maybe that would be a good physical representation of what you are looking at when you look at the range. Yeah. Okay, cool. Cool. So do you guys see how this stuff makes sense to you, or does it make sense? Let me take a look at your homework real quick. I just want to see what that thing's all about. Because I think that was one of your homeworks that I just covered with you. And you literally just talked your way through it. Statistics isn't bad. In fact, I kind of feel like you guys are going to like statistics. I hope you do, at least. Let's see. Oh, yeah. There's no surprises. This is in fact, this is one of them I did for you. So there's your homework. I literally did like 3 pages of your homework for you. There's only 4 of them. But I don't feel bad about doing that mainly because I'm not doing your homework for you. We're discussing, we're going through, we're talking about them. Let me take a look at this one real quick. Okay, this is one I didn't go over. This is the next one I was just about to go over. See? Right there? That's the same one. I'll let you guys figure that out. Do I make you guys do introduction to histograms? All right. Well, let me talk about a histogram real quick. Essentially, I was supposed to introduce you to number plots and dot plots before I introduce you to histograms. But the thing about it is, a histogram and a dot plot is the exact same thing. The only difference is the histogram has, you change the bin size. Does that make sense? No, it doesn't have 2 axes. You just change the bin size. That's it. So what you do is you say, all right, let's look at this data right here. And let me just type it up as quick as I can because I'm going to go in about 5 minutes. All right? Okay, let's add more data. And I'm going to go 100, 330, 190, 220, 235, 190, 245, 260, 295, 165. Okay, all right, no, here. I got a better idea. Okay, what if I asked you guys a question like, how tall is everyone in this class? Okay, how tall is everyone in this class? Okay, and what I'm going to do is I'm going to get answers like 6 feet, and I want you to convert it to inches or whatever. So, we'll go 6 feet, and then let's pretend that these are the numbers. I don't know, but even more so, let's pretend that the data has like 0.25, and then this data has like 0.37, and then this data right here has 100.5 or something like that. I'm just pretending, okay? I don't know necessarily. I'm just making this up, okay? So here's the question: is if I did a number plot, does this piece of data right here get a totally separate bin than that piece of data right there? On our previous plots, we had different lines. We had different things right here. And yes, I agree with you, Sophia. Maybe if we want to be completely, incredibly accurate, then yes, we would, put one line for each data point that is absolutely different. But to be honest with you, then, if that's the case, then we'll only get a bunch of 1 lines. Would you agree? because everyone will be different by just a little bit if we include like two decimal places, and you'll have, like the height of your graph will be 1 all the way across the board. It will basically look like this, but the entire graph. That doesn't give us any good information. So what I should do is I should say something like, no, I think that what I'm going to do is I'm going to group them a little bit. I'm going to cluster them. So if you're anywhere between 100 and 110, I'm going to group you together into one category. And if you are anywhere between 111 to 120, I'm going to group you into another category. Does that make sense? So what I'm doing here is I'm changing the bucket size. I'm changing the range that is allowed to go within the bucket. And that's all a histogram is. It's a number plot that we've been doing. Actually, the number plots that we've been doing are all histograms with a bucket size of 1. Well, in this case, we can now change our bucket size to be something a little bit bigger, so that way we can have a better plot for us to understand. Because say that the data is a little bit different. If we were to do a pure histogram where we wanted something super accurate, it would be completely useless to us, because we would have a different line for each one of these pieces of data entries, because they're all different numbers. Oh, except 190 and 190. That's a repeat. I see that. You see what I mean? But like 190 and 195 would be a different bracket, apparently, if we were going super accurate, and then it wouldn't really give us a very useful data. Whereas if we made a little range of it, it said it can be between here and here, then it falls in this bucket, and between here and here, it falls in this bucket. It will give us nicer data that we can work off. Yeah. Well, you say smaller ranges. What I mean by that is, I like to think of these as buckets, right? And then you can drop your. So like here, let's go back to this kind of thing. This was the number of minutes a kid stood in line. And imagine I have 7 different buckets out there. And I put 5, 6, 7, 8, 9, 10, 11, 12. And I say if you waited 5 minutes, put your name in here. If you waited 6 minutes, put your name in here. If you waited 7 minutes, put your name in this bucket. Okay. Then I'm going to have some smart aleck student say, "Well, I waited 7.5 minutes, and there's no bucket for me, Mr. Dalday." And I'd say, you know what, round it off to the nearest minute. Cool. Right? So, like, what I'm doing is I'm giving you a range of what you can, because it could be, I go for 3.1415 minutes. And then when I get there, I eat pie, and then I would say, well, you put your bucket in the 3-minute bucket. Put your name in the 3-minute bucket. You know what I mean? That way, I don't have to make different buckets for each of your numbers that you want to make. You want to report to me super accurately. Like, I waited 6 minutes and 42 seconds. Okay, fine. Put it in the 6-minute bucket. You know what I mean? That's the point I'm trying to make. Are we cool? That's what a histogram is. Awesome. Dude, I think that was a good lecture. Anyway, I gotta go. Class for physics starts 1 minute ago. So I better start that up. Alright, talk to you later. Okay, bye.